Well, following on from last episode, when Alan was very kind about my GitHub organization and presentation, I have been tailoring my GitHub repositories. And I do believe that Alan finished his segment saying if anyone had any suggestions for how he could continue to improve his GitHub repositories in 2026, he'd be open to suggestions. Well, I am delighted to tell you that the tool I've had at the back of my mind for some time, I have turned into a real boy, and I have created a tool called Tailor.
Now, is that tailor as in a tailor who cuts cloth and stuff, or is it tailor as in just T-A-Y-L?
Taylor Swift.
Yeah.
It's Tailor as in a cutter of cloth. And I have leaned into the tailoring metaphor really hard with the way that the tool is used and the commands that you can run. So you can use Tailor to measure, fit, baste, and alter your GitHub repositories.
Now, most of those I was familiar with the tailoring terms, but based, isn't that something you do with a roast chicken?
So it's based, B-A-S-T-E, and a based is when they have the chalk outline and they temporarily stitch the suit to try it for size before they finalise the stitching.
Right, we'll see how that metaphor holds up in a minute.
Yeah, you'll have to judge my metaphors here.
This podcast is a never-ending journey of learning new things and terms for stuff. Thanks.
I love it when I find a really good metaphor for software, and I'm quite happy with this one. So my catchline for Tailor is ready-to-wear project templates for GitHub repositories. So that's the one-liner. And in terms of why I made this tool, we kind of touched on it in the last episode. You'd just done this audit of your repositories, and you were trying to sort of improve the quality of what you had. And I think I said during that segment that my problem wasn't the sort of the presentation, but it was more the inconsistencies that I had between different projects and different repositories. So it was things like some of my projects use issue templates and some don't. And the ones that do use issue templates, some of them use the YAML template language and some of them use the Markdown template language, and they're not actually the same.
To be fair, I did actually have a lot of inconsistencies. You remember we talked about all the different like YAML, YML and like naming stuff. So yes, this is exactly the kind of problem that I was trying to solve.
Yeah, so this is precisely what it's intended to do. And it started out as a shell script when I prototyped it a little while ago, but I have turned it into a proper application. So what it has is it has a single YAML configuration file. So it enables you to define your GitHub repository and what are called community health files as code using a YAML. And it comes with a templated YAML. So the things that you can manage with Tailor are GitHub Community Health, which is things like code of conduct, security policy, contributing.md, support.md, and then things like the issue templates and the pull request templates. And additional things you can do in the pull requests and issues that I didn't even know about, which are kind of fabulous. So it can manage all of that, and then the settings for the repository as well. So things like what license are you using? If you haven't got a license, you can specify one. Whether you have got the wiki enabled or the issues enabled or discussions and projects, you can turn all of that on and off with just a true or false. But then also the things that really bother me is I have very specific preferences around whether I want merge commits enabled, which I never do. But I do want rebase commits and squash commits. So you can configure all of those attributes of like how the repository is configured as well. So it's a single YAML. And then the other thing that I suppose it's a little bit of OCD, but it's having the same issue labels, the same names for the labels and the same colors, so it can synchronize all of that across your projects as well.
It sounds like there's lots of sort of standard GitHub stuff that this manages. But if you had a bunch of repositories which had some other stuff in common, does it let you extend that and have some other standard files that you apply in any way? Can you like add your own templated template?
Yes. So this is really designed for sort of solo developer projects and small team projects where you just want all of the community health stuff and you want things like Dependabot configured, but you don't want to have to deal with all the overhead of doing that. You just run one command and it scaffolds all of this. And each of the templated files, you can say whether you want them to be altered always, and I'll get into what the altering is, or whether you just want them to be dropped into your repository on what's called the first fit. So the first time it runs, and then it won't update them again because they're things that you may want to edit over time. Some of the configuration options, and you can also say never alter these, which means it will never deposit them.
The implication is that you're running this repeatedly in what, a GitHub action. This is not a thing that you just run once in order to scaffold up your repo and then you're done.
You can do both.
All right.
So you can run it once and forget about it. But if you are me specifically, and you know that I'm going to update the security policy, and I want that reflected across all of my projects, it also has a companion action, and it will on a weekly basis update itself based on the current version of Tailor and the things that it provides. So it's like a policy engine if you want it to be that.
So you would have a central repository with your template for Tailor to run against all of your repositories.
Yes, the repository for Tailor are called swatches.
Oh, God. So if I've got, I mean, I'm not you, I'm me. And so in my GitHub, I have a pile of repos that are just snap configurations. So Snapcraft YAML and a few other bits and bobs. And then I have others which are my own applications. And then I've got others which are forks of other applications. And in the Tailor config, I guess you specify exactly which repos are covered by that config. And you have multiple sets of config. So I could have one set of config for the snaps, one set of config for my own applications, one for Go apps, one for Python or whatever.
So it doesn't care about like your project and what the specifics of your project are. This is just to give you the general stuff that's generic across all of them. And you can run it once in a repository and forget about it, but you run it for each repository. So you would go to application A and run Tailor fit, and it will drop its configuration file in, and then it will drop in the templated files on top. And then if you run it through an action, it will repeatedly, apply the updates each week. But the idea is that it's nothing project specific. And if you've already got some of the files in your project, it won't overwrite what you already have with its version. It will leave, your stuff that you've already created.
It kind of can be project specific though, can't it? Because if I've got a bunch of snaps that are just YAML, and if someone files an issue, I want to capture different information for snaps than I do for applications which are my own, because applications which are my own, I might want to know in the issue template where they got the application from. Like, was it from pip,
right,
or was it from here or there? Whereas a snap, I don't want to ask that question because I know where they got it. They got it from the Snap store. So you do still need some variance, don't you?
Yeah, and so the way that you do that is you could run Tailor for the first time, have it drop the issue templates into your project, assuming you don't have any, and then you can change the Tailor YAML file to say never update these again.
Right.
You can then go to those templates and then add the additional bits that are relevant to your project. But what it means is that every time you start a project or every time you fit Tailor to a project, you have a consistent set of things. And if you only ever run it once and never tweak anything, the generic templates it comes with are good enough for any project. They're designed to be useful regardless of, what you might need, but you can override them.
And so you would do all of this, like forgetting the GitHub action, but you would do all of this on a clone of your project if it already exists, or in a directory where you've just done a git in it and you're starting a new thing.
Yeah.
It would be like a brand new thing that you'd run Tailor in. And so
yeah,
could it also be used in repos that are not hosted on GitHub, like on GitLab, where they support similar files of similar styles as GitHub does?
It can't really. I mean, it can, but it is designed to work with Git. To give you an idea, it's implemented in Go, and originally it was a shell script that used GH. And because it's implemented in Go and GH is written in Go, it actually under the hood uses the GH Go module. So I haven't written any of the authentication stuff or any of the API stuff. It is literally like a trimmed down version of GH that is highly specialized. So whilst there are a couple of components of Tailor that could work without any GitHub integration, it is really quite sort of tightly coupled with expecting a GitHub repository beneath it at the end of the day.
Got it. What's the future of Tailor?
Well, I've put it on 3 of my projects, and I will be going around all of my projects and using Tailor there, so everything's up to date. But it was an opportunity to learn some more Go and Go releaser, so it releases packages for everything. So I've now got a homebrew tap archive in my GitHub that it's being cross-populated, and I can now publish multiple projects to this one like repository for all of my homebrew apps, and it does the same for a Nix packages archive. And I've even resurrected my AUR account, and it publishes directly into the Arch Linux AUR and creates Docker images and all the toys. So it's been quite the journey learning how all of this stuff works. It needs a little bit of presentation work, but it's functional. And so I'm going to be using it to instrument all of my projects so that they now will be consistent and behave in the same way.
Gather round and listen as I tell you a tale of woe.
Uh-oh.
I decided it was high time I retired my HP microserver, and it didn't go quite as well as I'd hoped.
I thought you'd done this.
Well, I had stopped using it as my always on server, but it was still my server with my redundant disk array in, with all of my like big media and my on-site backups. So it came on when I needed it and then turned off when I didn't. But one of the use cases with it, because it had my media on, was my Jellyfin server. And as I've discussed before, that comes on demand. But it took a very long time. And sometimes when you tried to play something, Jellyfin fell over, and this wasn't on. I couldn't have it go on like this. So I decided that, I mean, it's...
what generation of HP microserver is this?
It's a Gen 7 with the N36L CPU. You might remember HP did these very cheap with like £100 cash back, so they only cost about £100 back in the day, back in the days of the early Ubuntu podcast, in fact, I believe. So anyway, I thought I would go out and buy myself a slight upgrade, a microserver Gen 8 with, I discovered you could upgrade it to an Intel Xeon CPU. So it would be much more powerful, slightly smaller in size, but still fit all my disks in. Well, almost. So it turns out that these servers are a bit fussy about which devices they'll boot from if you want to install Ubuntu on, for example, the disk in the optical bay, and then have all of your 4 disks in the front bays managed by Software RAID. You have to have your disk in the optical bay, and then you have to have basically a USB stick inside to boot from.
What?
So I worked all of this out, and I got it working, but then it turned out that because of my habit of trying to reuse stuff that I already have before I buy new stuff, I was using disks of somewhat questionable provenance, shall we say. The SSD I was using to actually install Ubuntu on was a 32 gigabyte mSATA SSD in a case. Now, I cannot remember buying a device with a 32 gig SSD in since my EPC.
That's what I was thinking it's from, yeah.
So I had a few issues with data corruption on my first couple of installs, At which point I thought, yeah, I should probably buy a new SSD that I know is good. So I did that.
What can I just ask? Why was it having trouble booting? I've not heard this story of it having trouble booting from a drive in the optical bay, and you have to use a USB stick inside the device.
It will boot from the first disk in the front bay, or it will boot from the RAID array if you use the hardware RAID controller, which can include the disk in the optical bay, but it won't let you select at boot time if you're using it in non-hardware RAID mode. It won't let you select the optical bay drive to boot from.
That's weird, because that's exactly how mine's set up. I have a Gen 8 and I have an SSD in the optical bay and then 4 drives in the other bay, and I don't use hardware RAID. I use MDADM. Well, I did use ButterFS, but we don't talk about that. It's interesting. I wonder if it's a firmware thing or generation or something. Or
I remember I remember having to like flash the BIOS with an aftermarket BIOS to work around some of this stuff.
That is an option, but it's not an option I took. Anyway, let me continue, dear reader, with my tale of woe. So I got some new drives and I got everything set up and it all installed and booted and it was working. And then the case fan died.
Oh, this is what that message was about case fans.
Yes. So the problem with the case fan dying is that's one of the things that it checks during the power on self-test.
Mm-hmm. Oh, gosh.
So
it won't come on?
It will come on, but it won't let you boot anything.
Oh, my God.
So I trawled the internet and found a seller in China who sold these particular case fans with the particular connector they have, and I ordered one and it took 3 weeks to make its way across the world, and that didn't work either.
The fan was dead.
I believe it must be a fault on the board, possibly a fuse or a short or something. Anyway, it was at this point I decided to stop throwing good money after bad and have a rethink. And this made me realize that I was seeing my problem as a microserver shaped problem with a microserver shaped solution. And that really isn't the case anymore, because I don't necessarily need a box sitting in my server rack in my garage, because it's not always on. It doesn't need to be there and out of the way and out of earshot. All I need is a device which can carry these 4 drives with all of my media on.
You bought a Drobo. Is that what you did? You went... No.
Even more old school. Yeah. So I went looking around and I realized I have a tower PC sitting under my desk here, which is my quote unquote gaming PC, which is now mainly used for video encoding and other bits and bobs. And I opened it up and I had a look and I thought there's just about space for 4 disks in there. So it's already got a couple of SSDs in there in the drive bays. There's another drive bay free and there's one more drive bay, but that's obstructed by the GPU. So I could fit one in there. Then I looked around a bit more and I realized that there were 3 spare optical bays. So I've got a Blu-ray drive in one and there's 3 spare. So I bought some adapters and I managed to mount the discs in there. So we're going good so far. Next, I needed to actually connect them to the board. And the motherboard had 4 SATA connectors, 2 of which were occupied by SSDs, 1 of which was occupied by the Blu-ray drive, and the other was obstructed by the GPU.
I think you know the answer to this, or one of the many answers to this, which is remove the GPU and stop faffing about.
This is games machine.
I know.
Yeah, it's no good without a GPU in it, man. Come on. So what it does have is a spare PCI Express slot right next to the GPU. So I couldn't install a card directly in the slot because it would be obstructing one of the GPU fans. But what I did find I could get was a ribbon cable with right angle connectors to move the PCI port laterally, so it's next to the motherboard. And I got a PCI Express card with 4 SATA ports on it, which could install in the case and then plug into this ribbon cable. Finally, I had to power all of these drives. And fortunately for me, when I bought all of these bits, I massively overspec the PSU. So
Mhm.
when I went digging around and fishing out all of the ribbon cables, which I'd tucked neatly away, mostly in those spare optical bays, it turned out I actually had 4 spare SATA power connectors in there already. So with a bit of jiggery pokery and untwizzling of things and shoving the GPU out of the way a bit, I managed to get all of this connected. And something I hadn't realized about MDADM, which is very cool, is that if you whip all of your drives out of one machine and stick them in another, and it's running MDADM, it just says, oh yeah, you've got one big device there already. You don't have to tell it. You don't have to reconstruct the array. It just says it's there, mount it. And now it's all working. So I now don't have a microserver in my estate. I just have my always on Wise thin client in the garage. And my quote unquote gaming PC now comes on when I need it and provides the big storage.
So that's still a Wake on LAN device, your gaming PC with loads of disks in it now?
Yes, it is.
Okay, so given that your Wise device, is that connected to the telly in the front room?
No, that's connected to the network in the server rack in the garage.
Right, because it's the thing that actually does the streaming of the telly, but it gets its data across your network from your now gaming PC with disks in it.
No, Jellyfin is running on the big PC, but it's reverse proxied through the Wise, which is how it triggers the Wake on LAN. So all the requests go to that first, and then it says, is Jellyfin available? If not, then do the Wake on LAN.
Can I ask what you did with the Gen 8?
Put it on eBay.
Okay.
4 parts are not working, of course.
Oh, because you've now found out that the fan ports don't work and it doesn't boot properly. Yeah, it's no good to you, Alan.
Shucks. In a recent episode, I mentioned I'd been updating some snaps that I'd been maintaining for a long time. And I noticed that I wasn't aware if some of them worked on RISC-V or not. And they were building for multiple architectures. I could test on AMD 64 on my ThinkPad. I could test on ARM 64 on my Apple MacBook Air M1 running Asahi Linux. I could even test ARM HF if I really wanted to by digging out a Raspberry Pi, but ain't nobody got time for that. And I guess I could test on i386, but nobody uses that. And most of them don't even build for i386 anymore. But the other architectures that are supported in Launchpad include PowerPC, PPC EL64 or something, or 64EL, and RISC-V and S390. And I thought, I'm curious. I wonder if it's possible to get a RISC-V machine of some kind, and whether it would be any good for testing snaps, like graphical ones, desktop ones. And so I asked on the Ubuntu Discourse, what's the best RISC-V device to buy? And the basic answer was don't. And there are yes, it's not very confidence building, is it? There were good reasons why. There's some transition to a new ISA, the instruction set architecture, or whatever it's called. The architecture that defines the instruction set. And there's some change happening at some point, and the general consensus from the experts who are working on this stuff was wait for this, and then it'll be supported in the next version of Ubuntu. But I'm impatient, and I wanted to figure out some other way. And someone else said, well, you could just use QEMU and run it with a different architecture. And I thought, oh man, do I really want to try that? But I did, and it works. I was able to run RISC-V Ubuntu desktop in a VM on my ThinkPad.
RISC-V Ubuntu desktop?
Yes. RISC-V Ubuntu desktop on my Ubuntu system. And boy, oh, howdy doody, it's slow.
Yes, I bet.
Right. That was going to be my question. So this is this is emulating not just like the nice quick virtualization we're used to, it's actually emulating a different kind of processor on your AMD 64 processor.
Yes, and that's fine. I'm used to like doing emulation because I've been doing emulation of CPUs, but mostly things like Z80 and 6502 when I'm playing games, not like full graphical desktop environments. But it is usable. It's not a daily driver, but it is usable. Usable to the point where I could open a terminal, snap install something, launch a graphical application. In this case, I was testing Notepad Next, which is like a Notepad++ re-implementation. And it worked, RISC-V. I was like, brilliant, ship it. And so I then published that RISC-V build of that in the Snap Store. And I thought, this is great. I've now got a system that I can use to test RISC-V builds of software that I've packaged. And then I thought, hey, there's some other architectures here. There's one called S390. I know someone who works at IBM. And so on Mastodon, I tagged Liz, who is part of the Ubuntu community, has been around in the Ubuntu community for about as long as I have, works at IBM. And I said, hey, is there anyone who has an S390 I can log into? And she said, why, yes. They have a system called Linux One, Linux ONE, if you want to Google it. And it's a thing where you can request access to an IBM computer that has an S390 CPU inside it. And she sent me the form and I filled it in.
So I've heard of, ARM and RISC and PowerPC. What on earth is S90 and why do only IBM have them?
It's not only IBM that have them. I don't know the full lineage, but if I were to say the word mainframe to you, then like that's the kind of lineage. It's like big iron computers from IBM,
right?
And they have their own
reel-to-reel
CPU.
tape drives.
Yes, all of the Winchester discs and like Daisy Wheel, and golf ball printers and all that kind of stuff from the past. No, it's not like that at all. They do big computers, but you can carve them up and put different operating systems on. They've got their own Unix-like operating system, AIX. I don't know if they still use that. But you can also run Linux on these partitions of a machine. And the CPU inside, the architecture, just like AMD 64, is called S390X. And the machines are generally called S/390. And there's all kinds of these machines that generally have a letter, then a slash, and then some numbers. And they date back to the 1960s, I think.
OS/2.
Yeah. When I was working at Canonical, I got dragged along to some sort of sales pitch for IBM at the facility where they design and manufacture the mainframes. And walking into the room with a long corridor, and all along the walls was the main boards and memory chips from the very first mainframes that they'd made in the 60s all the way through to the current day. So it's kind of like a walk-through museum of, the whole history of IBM mainframes.
However, flush all of that out of your head. Forget about all that old school mainframe stuff. We're talking here about a 5 gigahertz multi-core CPU type, modern system that can cope with significant loads. We're not talking like, that's just the lineage. They've been doing this for a long time and they know how to do this. Anyway, I filled in this form that Liz suggested, and I detailed what I wanted to use the system for. And I said I wanted to test some snaps. I'd probably want to install some compilers and build some software, and said I'd quite like to be able to test these things not just on Ubuntu, but on other operating systems as well. So if it's possible to put Red Hat or SUSE or something like that, that would be great. And I said I'd like 16 gigs of RAM and 100 gig of storage or something like that in case I wanted to put a desktop VM on there or something like that. And it was approved. And then I suddenly had access to a web front end where I could press a button and launch a VM on a machine, which is at Marist College in the USA in a place called Poughkeepsie, which I like the sound of. And I have been SSH'd into that for a few days and running snaps and building things and fixing things. And it has been a really pleasant experience because I just filled in a form, I got access, I spun a machine up, SSH'd in, and I'm away.
When you said filled in a form for access, I was expecting you to say, and I had 4 hours or 5 hours to do what I needed to do, but you're still using this thing.
Yeah, it's mine. It's allocated to me.
For how long?
Well, until I stop using it, I guess. I'm not the only one. Like, anyone can request this who works on like open source stuff. And I said to Liz, like, I'm happy to talk about it on the podcast if that helps, like, because it's a great service. Like, I've got a remote machine that I can build software and actually test stuff as well. So at work, we have this piece of software called Tesla. It's a command line tool. And I thought, what happens if I run the installer on this S390 box? And so I ran the curl pipe to bash installer thing, and it said, unsupported architecture, S390X. And so I then pasted that into our company Slack, into the command line, a CLI support channel, and said, here, look at this. And someone replied, what on earth is S390X? And I was like, oh, sweet summer child. Someone Googled it and was like, oh, it's some IBM thing. And then another answer was, who gave you access to an IBM thing? And I was like, well, IBM. So that's why.
Yeah.
Anyway, I've really enjoyed this, and it has allowed me to audit all of my snaps. I've got like 50 of them. I've only done the CLI ones so far, and I was able to group them by, does it build? Does it release to the store? Can I install it? Can I run it? Can I test like all the features of it? And I've like broken them all down. I've got a little markdown table with them all grouped together, and I'm slowly working through each one. And the first one that I had quite a significant success with was Forgeo, the CodeForge, which builds for AMD 64, ARM 64, and now S390X. And so there is a build in the Snap Store of Forgeo, and it's published, and I have installed it as a code hosting platform on my IBM S390X based system, and it works. So I was really pleased that I would have access to this system. I haven't even booted up the Red Hat and the SUSE ones yet, because I've still got stuff to do on the Ubuntu one, but I'm slowly going through testing these things out. I'm happy to test other people's snaps and provide support, and maybe I'll be able to fix some other things as well. I've certainly made a start on fixing things that are outside the scope of the snaps, but because I know many people don't have access to this architecture, so they can't test this stuff, and they don't know the various ways it breaks. One way it breaks is endianness, which I did not realize in 2026 was still a thing. Big endian versus little endian, and more on that another time, because I've already spoken about this for far too long. But yeah, it's really cool. I'll put a link in the show notes to the Linux One page where you can find out more about the project and see the systems. And they're not all crusty, dusty motherboards. They're like modern computers with decent speeds, good specs, and nice people who provide access to them. So thanks very much.